Okay, so we've talked about the bulk modulus, which relates the pressure to a change in volume. That's one aspect of our constitutive relationship. The other one is thinking about changes in shape. And so to talk about that, we're going to talk about a case of pure shear. Okay, so we're going to have our axes here again. Here's X, here's Y, here's Z, and I have some block of material here. Okay, and so we've talked, this is our block of material. And we've done something similar before. We're going to talk about some different faces here. So I'm going to color code those. So there's the green face. Here's the red face. And here up here is the blue face. Okay. And we're going to essentially look head on at each of these faces. So we're going to start like we're looking head on our red face. Then we'll think about looking at down on our blue face, and then we'll think about looking directly at our green face. And what we're going to end up doing is we're going to end up applying a shear to the block in that square, and we'll talk about the relationship between the shear strain and the shear stress. And our assumption, if we start off with that, is going to be that if we have a block of material and we apply some shear stress, tau, and we have shear strain here, that our linear elastic assumption is still good for modest loads. And so we'll have a linear relationship there, and the slope of that is going to be G. So again, this is the shear strain. This is the shear stress. And this is the shear modulus. And so, again, remember that this gamma is just twice the epsilon for that particular plane. And let's draw some more pictures. So we have three faces, and so we can think about each of those separately. So here's the first one. We're going to look at the red face first. So in that case, we're going to have Y and Z. So I'm going to put Y here on the bottom and Z on the top. Is that true? Let's put the Z one here. Sorry, that will be more in line with our picture. So if we look that way, we're going to have Z on the horizontal axis. We'll have Y on the vertical axis here. Our square, if we apply some shear stress to it, might end up looking something like this. Okay, so here's our shear stress. That's tau. And this is going to be tau YZ. And we'll have some stresses going the other way on this face. Over here, we're going to have a change in angle, right? And what is that change in angle? That's going to be gamma YZ, which remember is equal to 2 times epsilon YZ. Okay, so if we want to know what the shear stress is, tau YZ, that's going to be equal to G times the gamma. So we have gamma YZ, which again is just going to be twice the epsilon value. Okay, so that's one face. We can do the same thing on the blue face. When we think about the blue face, now we're looking down, so that's going to have X and Z. And we can have our square again here. We'll have some shear stress. And that was going to be our shear stress XZ. And we're going to have some change in angle right there, which is going to be gamma xz. Again, that's twice epsilon xz. And we can write the same expression here. Tau xz is equal to the shear modulus times gamma xz, which is equal to twice shear modulus times epsilon xz. And as you had probably guessed, if we do this again for our green square, I'll try and do this quickly. I know you're probably bored of seeing the same picture. We're going to have a picture that looks like this. We're going to have tau xy. We're going to have gamma xy, which is equal to twice epsilon xy. And our shear stress xy is going to be equal to the shear modulus times the shear strain xy, which is going to be twice g epsilon xy. So we have 3 independent directions, and we have 3 independent quantities. So there's no interactions between these guys, which is important for thinking about later. I will circle all of these because these are important. And the thing to remember here is that we have 3 independent actions. So we have a shape change in the YZ plane, we have a shape change in the XZ plane, and we have a shape change in the XY plane.